Good morning, good afternoon, good evening, everyone. Welcome on the next live Learn Grasshopper live session. Again, we are continuing our series about Rhino inside Revit. So it's a third episode. So welcome. I have two guests today with me, Junghwo and Ching. Hello, can you hear me?
Hello.
Hi. Hello.
Hi.
Hello.
Yes.
Where are you both based in Austria right now?
Yes.
Yes.
Yeah, but not in you are Junghwo based in Vienna. But you,
Yeah.
Ching, where are you based?
I'm based in Lower Austria, a city called Krems an der Donau.
It's like a village or a small city or
a small city. Yeah, it's a small town. Let's say countryside.
Perfect. We have already some people. Just let us know if you can hear us and see the screen, and if you can hear all of us. So today, Junghwo and Ching, they are representing their YouTube channel. They are YouTube creators. So they have own channel. It's called Spot, a single point of truth. So please let me know just in the introduction. What are you doing on your channel? What kind of content you are creating, Junghwo?
Yep.
Who was are you both created that, or you were the first?
So I was a founder of Point One Studio, which was original YouTube channel. So you will see some of the recording history, some of the logo with Point One Studio. And I felt I need to scale up, and I was always seeking for a good partner. And luckily, I met Ching-Hua, and we had similar mindset and some strengths and weakness in between us. So we decided to team up, and that was named as a Spot. Actually, end of last year. Yeah, we for personally myself, I'm BDC manager and encouraging more different technologies that could be applied for building information modeling. And I'm interested in also computational design and parametric design. And is more specialized in programming in architectural design and process. So we have clear different division between my role in that spot and Xing. Xing, please go ahead. Also, your
Same mindset we have, and why it is called single point of truth is that we want to share our knowledge on the channel, because also we are both architects as a background, but we have different approaches.
And you are
so
both Revit experts, right?
Yeah. We did lots of different things,
so.
and one of that. Yeah, and that's why we want to share the knowledge, and it's a single point of the true knowledge to share it for everybody.
Perfect. We will start in just 2 minutes. We have plenty of people right now. So we have Roman, we have Muhammad, we have Big R, we have Ayub. So a lot of people with us today. We have a little bit different time slot than usually. So I hope that will be also different people from different places, as Australia or maybe even west coast of United States, since there's evening there. Okay, so just for those who are with us on a live, just let us know, share what is your experience in using Rhino inside Revit. So please write in the chat below. One, if you never heard about Rhino inside Revit. 10, if you are expert as Junghwo and Ching. You can guys write in the chat 10. So so we will see. We have some 4, some middle 5, Mr. Chang 5. Okay, so we can see we have some zeros. So we can also be careful not to make advanced stuff. So there are some beginners as well, but for now we have 5 as a maximum. Okay, guys, so just keep it in mind when you're going to present. that for now 5 is maximum. So there's not that many experts here. So just please keep it low. We have Magda. Hello, Magda. Yuri, 3. Okay, Olga. We have Olga Balunova, number 7. So Olga will be expert today and check all of your work. Okay, we have 10 a.m. Central European time. Let's start it. We are live on Facebook, LinkedIn, and YouTube. And as always, please leave a like or share it, make a comment. It will help us to grow this channel and share our knowledge. So today workshop, we aim for 19 minutes. Session time, we will try to make 16 minutes as a content, and there will be 30 minutes for all the Q&A session. We will try also to answer all of your questions in the meantime. Recordings will be available to watch later, together with a Revit file, with Grasshopper file, and Python file that will be presented today. So this is a workshop. That's why you are going to get all these materials to walk at your own tempo and go through materials. And remember, this session is made for you, for all listeners and who is watching us. So if you have any questions about RHINO.INSIDE, Revit, Python, architecture, engineering, structure engineering, so please let us know. We are here to help you. For those who never seen me, my name is Chris. I'm an online educator. I'm also, as Junghwo and Ching, a YouTuber. I'm educating engineers and architects to transform their work into fun with programming. So I started 2 years ago with my newsletter. I have 15,000 people following the newsletter. And now we have learning platform where we are teaching Grasshopper, Python, C#, and usage of these programming languages in different software in the AAC industry. So in December, on the 18th of December, we started this RHINO.INSIDE.REVIT series with the first workshop with the direct shape with the Mohammed Shakline. It's still available for those who haven't seen that. It's still available to get the recording and all the materials to catch up with the first series. The second one was Jaffe from McNeil, one of the creator, one of the people that stands behind RHINO.INSIDE.REVIT. So I was really happy to have Jaffe on this workshop. He shared his experience, the best tips and tricks how to use RHINO.INSIDE for families. And today we have 2 YouTube creators. We have Ching and Junghwo that's going to share their knowledge about how to use RHINO.INSIDE.REVIT into structural design. So this session is both for architects and for structural engineers. Junghwo is going to make an introduction for the structure design. So we will try, as you guys saw on the chat, it was as an average, it was 4 knowledge of RHINO.INSIDE. So please keep it low. So Junghwo, so we can start with your presentation. So please share your screen. So we will start and we will go to the session.
All right. Can you see my screen?
Yes, it's coming, and we can just share it. So yeah, so tell us what we are seeing.
Okay, so I would like to present particularly how architectural plannings and structural design at very early stage can collaborate. And because when you think about in practice, architectural design and structural design from the early stage always coordinate each other. But there are still a lot of challenges because of many conceptual idea is not really known by architects as well as structural engineer. So when you go for architectural concept to structural concept, the architects design general scheme of the building, and structural engineer take the core of this building structure and suggest the concept. And of course, in structural model, we have an analytical model, which has, if it's building project, we have building elements, and those are something different than physical model. Physical model has exact thickness and material and parameters of those elements, but the analytical model is very simplified geometry. Sometimes you have to even approximate them, and those are big challenge how actual architectural model and structural model can be communicate each other. And of course,
sorry to interrupt you. So in most cases, we have differences, right, in the analytical model and the physical model. Is there any chances that sometimes they are the same, or they are always different?
They can have same parameters, non-graphical information such as material property, material thickness, and etc. The only difference between physical and analytical model is that physical model is representing real world geometry. So like if it's slab with 200 millimeter, it must be 200 millimeter, whereas analytical model is just a simply surface, but can contain the thickness information on the parameter set. Is it answer your question or?
Yeah, sure. Yeah, you can continue.
And what is big challenge later I'm going to introduce, analytical model has to be really precise. If there is any gap between each node of those elements, you're pretty much going to end up having error when you calculate structural analysis. So there's another components on the analytical model. You have boundary condition. You can think about different boundary condition. And also there is load. You can set point, line, and area load, and you can combine these load cases and use specific code that you can calculate later. Generally speaking, I have here visualization. So when on the left-hand side, you can see these are typical physical model, including architectural finishes. And what structural engineer at the very beginning needs is to look at the components, and from those physical components such as slab, beam, and column or foundation, they need to simplify or extract the analytical model from that physical model. And this have a lot of challenge in general because there are some different use case depending on a situation. And when it comes to complex geometry, the setting up analytical model without computational process is very, very challenging. So for example, here is one of the good case. The straight walls or slabs is easy, but sometimes when framing structure meets those complex geometry, to have analytical model accurately is very, very difficult. And if there's any small error between those node points in somewhere, we will end up failing to calculate your analytic structural calculation.
So all points that we are seeing in this picture is all the connection, right? So
yeah,
every single point, a bubble here represents connection.
Exactly. The green points are automatically connected, and the blue points are manually connected, and the red points are not connected, but it doesn't affect the whole structure. So this is a graphical representation. I'm going because it's end of the slab, for instance, or end of the wall. So that points, of course, that is not necessary to be connected.
Mm-hmm.
All right, so I'm going to move on to Revit screen. And especially today, we're going to introduce RHINO inside Revit, because RHINO has certain freedom of geometrical operation. And particularly, we're going to looking at in this Revit, RHINO inside Revit. It's still work in progress, what McNeil developed, but we're going to look at those new components which we can create analytical model from physical model or convert between physical model to analytical model. And that's, I think, is very useful in especially early stage when you get the architectural model from architectural designer.
For those who don't know what Grasshopper is, so they can think about like Grasshopper is kind of Dynamo, but better. is a good explanation.
I cannot really say, but they have both strengths. But Grasshopper for sure is very powerful when it comes to geometrical operation than Dynamo. Dynamo has also certain charming points, but the Grasshopper performs much faster when it comes to geometrical operation.
And today we'll focus mostly on geometry, right? About like
Yep.
making structural design is a geometry.
Exactly.
Okay. So yeah, we have lots of components, but some of the parts are just strictly for structural design. This is the components that we are seeing right now?
Yeah, these are the components we're going to look at particularly today, where we will create analytical elements from physical model, or we can add analytical model from RHINO geometry, such as curve or like surface. And we will convert analytical model, Revit's analytical model to physical model. And there we can set some kind of boundary conditions. And there are still a lot of components are missing from RHINO.INSIDE.REVIT. I assume they are busy to keep developing those components. For instance, setting up the load or adding load is missing. And today, Ching will show how to customize the missing components by using Python programming.
Yeah, because it was introduced some couple months ago, right? This on this ribbon, and today I'm going also show you that you don't have to wait until every component is created. Ching later will show us how to create own with Python. So yeah, looking forward to this one as well.
Yes.
Yeah. So basically, if you count all these components right now, what's available in RHINO.INSIDE.REVIT, if you remove text and grouping, when I counted, it's about 456 components at this stage.
Really? It's a lot.
It's over 450 components are available, and particularly the structural components. To be honest, I add first time as a feature request to McNeil's forum, and also their GitHub issue page or the ticket page. And luckily, the McNeil developers are very responsible, and they really hear what you need. So if you really need some feature request, you can always ask to McNeil's forum, and when it makes sense, they really develop. So I'm really appreciate, first of all, also the JP and Pedro and Kike who accept my request for those components, and they promise to keep developing those areas. So I'm really excited to present. But before I'm going to show the RHINO and Grasshopper definition, I'd like to also a little bit explain in this short video how those architectural concept or structural physical model can be analytical model in theoretical level. So I'm gonna play my video. Can you see my video? Okay. Yeah. Let's imagine here we have architectural conceptual design, and usually structural engineers take that core or shell of the structure, and they start to prepare what kind of structural concept should match to main structure or facade structure. And for instance, here we have structural slabs, and structural engineer usually take this slab, typical slabs, and get the center line of the slab and creating analytical surface. And if there is a column, they from physical model, they extract analytical line and apply as a structural column. And at the end, you have very simple static geometry. And also we have to think about boundary condition. And here, when you have different framing, for instance, downside beam, the beam also has to determine which orientation and where the structural analytical line must be aligned. And so the structural engineer has to determine all this kind of complex at the end to connect all these node points and bounding condition to calculate their structure. And when structure goes up and up, up or down, there are some certain complexity. They need to think about the loads, and the load depends on which kind of load case they assign to each analytical surface or elements. And when it comes to the multiple components joining together, for instance, here between wall and column, you might end up a small gap because of the deviation between physical model and analytical model. And some software requires to connect them, even though they should be there a gap. But some software doesn't matter. Even though there's gap, they can recognize the thickness parameter of the analytical model. But what is important in this case is that because of building story is divided, and the analytical model is supposed to be also divided according to your building story. If you just create from the first up, it's going to be mistaken. And another challenge between physical model and analytical model, when slab is jumping, and you have to determine, it depends on the distance, would we make this as a wall structure between the slabs, or should we make it as a beam? There are some condition difference, like rigid condition difference, then the structural engineer should determine what's the best for the calculation. And when it comes to the beam systems, you also need to think about the nodes where it meets, and some of the softwares allows you to have that long span analytical line, or some other software requires you to split each division. And of course, the node must meet each other without any gap. Also, there are many slab openings happens in structural model, and when structural engineer calculate, they also determine do we need opening for this more, or should we simplify without opening? And this kind of use case is very important for them to think about all openings around. And when jumping slab is not less than, let's say, 30 centimeters, then they just approximate those two analytical surface as one level. So there are not super complicated calculation situation. And when it's a framing structure, of course, we need to think about nodes, and each node can contain different information, where it's fixed or where it's released, and if there's any rotation. So all this kind of condition structural engineer usually take into account. And when there is a beam which is curved, sometimes they approximate the geometry, and this approximated geometry with meeting another beam, and that beam analytical line must be connected to the approximated node points. It depends a lot on software, calculation software. Some software doesn't matter if it's curved, they don't need to simplify, but some software necessarily simplify the curved beam. And when slab profile is very complex, you can also approximate those complex slab edge and make it simplify for the calculation. And of course, stairs is kind of complex geometry, but when it comes to the calculation for stair, we just take the core of these stair structure and simply simplify that surface geometry for the calculation. So that's the kind of scenario. And of course, when the wall is single curved, we can also penalize it and make it a bit straight wall in analytical surface. But when it comes to double curve, then the challenges happens very complex. And as you can see, this is typical case between structural model, physical model converted as a analytical model, and that you can calculate in structural calculation software such as Sophistic or Caramba 3D, and that you keep communicate between BIM model and calculation model. So let me go to show you the example that I prepared.
Just before, I have to say that it's a really amazing video that you made it. So I assume that you make all these drawings and you make this video.
Yeah, I did it.
It's really a great knowledge refreshment for structural engineers, but I think it's also really important to understand the logic for architects. You're both architects, and how much knowledge the architect do they need to know about this structural design simplification usually? Architects care about it, or they don't care about all this structural design?
I have to say it really depends on their partners with structural engineer. But what I observed in my last 18 years of experience is that these days the communication between structural engineer and architects are very smooth. And many companies, they work together within one organization. So in my opinion, this kind of culture or workflow is more and more encouraged between architects and structural engineer. So in from my experience, I was working for structural engineering office and supporting structural engineers to have such a model, so they just can focus on calculation. It was lucky I was about 2.5 years working, and that was quite enough time to gain this knowledge. But I think, yeah, if you have structural engineers as a collaborator, then architects can always ask those questions to enhance their efficiency.
Yeah. Also, Regina wrote the comment that it's really good example and it's really nice presented. Chandra asked, we'll share the examples later. Yeah, all presented materials and Grasshopper scripts, Revit file, and Python file will be presented. Okay, so let's go to main topics today. So let's show us how we can use RHINO inside Revit, because like if you will do it in normally, if you have like a standard, let's say Revit model, and we would like to create analytical model, so it's two separate things, right? Like making it in the standard way, but bringing RHINO inside Revit, so we can actually make one model that can connect between two softwares.
Yeah. Right. So I have let's imagine this is a very conceptual, simple model, which modeled in Revit, and I'm just about to extract analytical model using RHINO inside Revit and generate those analytical model from the Grasshopper components. So we'll follow exact same theoretical part that I present with the drawings. What I'm gonna do, first we're going to, maybe I don't have enough time to explain all this part, but what I'm going to explain only key points. So at the end of the day, we'll just get this analytical model out of Revit components. And what I'm doing here is first we're going to filter and query the walls and floors and columns. And based on those Revit geometry, what's filtered from RHINO inside Revit components, we're going to distinguish, of course, certain parameter between exterior side and interior side. And when you have, let's say, geometry which is filtered from exterior wall side or interior wall side, it's kind of obvious. And the geometry is already now recognized as a Grasshopper preview. So it means it's RHINO and Grasshopper can start to understand these Revit elements as a RHINO and a Grasshopper geometry. And the operation I am doing to get to this stage is the rest is mainly Grasshopper logic. I'm just get the center line of the let's show, for instance, I'm just get the center line of the wall surface. Sorry, in this case, I push it to the slab edge to connect them, but we can control this kind of, if it's aligned to middle or left and right face, it's all possible using Grasshopper. So the definition here, what I'm doing is getting the wall structure, and then we're going to extract based on the wall location line we extract from Revit's wall geometry, and then from there we reference wall height from RHINO inside Revit components. We can analyze the wall, and this wall height applied to extrude the surface from Grasshopper. And there will be a slab thickness that the wall between wall to wall need to be met, and we just do simple calculation in Grasshopper to get that result. So this you can see, we can have analytical surface without any openings, but we can also get we can work with openings by extracting window or door opening information, and we just need to do simple Grasshopper operation to get the openings, and at the end you can get that geometry with openings, and we can set the design option. Sometimes I want to calculate everything without opening. Sometimes I want to calculate everything with opening.
And you're using just only native RHINO inside Revit components. You're not using here Python, any Python scripts.
Everything is native RHINO inside Revit components and Grasshopper components. No plugin apart from that. And it's also very important to mark. If I use specific plugin, I always group them with a particular color from this template, so we can indicate which components actually use plugin apart from the native Grasshopper components. Right? And the same story goes for floor. We extract the floor from the built-in category, we query them, and then convert as a Grasshopper geometry. And there's difference between slabs and foundation, so we can differentiate. Excuse me. And then here you can see at the end we get the analytical surface of the slab, and we can determine this slab going to be center or bottom or top. Right now the script is matched to to the center of the slab to align with all the verticals, but it's all possible to parametrically adjust all these analytical model. And I'm also extracting columns based on a particular parameter, and we just split that geometry of each level for the columns. And what it does is just the rest of script here is to get the center point of each column, and we just connecting those center point as a single line, and the line need to be extend to the slab level. So we just scale it up, and we shatter only the core lines what we need for the calculation, and then we convert all this to as a final analytical model. And
so
let's say
basically whatever, like if you have columns modeled in Revit in different ways, let's say they are families, so always you can make some simplification and make your analytical model as you want.
Yeah, exactly. For example, now this script, they are linked each other. If I move my column here, simultaneously you will see that the column analytical model is moved according to this physical model, and when I move it back, you can see the communication between them. It's very clear. And as you can see here, the nodes shows green points, means it's connected between slab and the columns.
Is it any function from Grasshopper that if the point meets a surface that turns green?
No, I just visualized it with a color point.
But it's you just meet when the point is meeting the.
We can set as a clash component, and when clash component shows number of clashed points, we can highlight as a for example color. For instance, there are many other solutions we can think about it for the quality control, but at the moment here in this script is just I'll just display as a green color.
Yeah, and I really like what you showed when you moved your column in Revit. I think this is most important thing because of all the changes, and it works also if you work in the multi-server with different users, right? If someone else is moving, let's say, wall or door or column, it will also update your analytical model, so you will get new forces and so on. And this is in my opinion, one of the biggest advantage of using this connection.
Exactly, that's the power of this parametric engineering, let's say. And there are some components highlighting error is just because there is no no relation for this particular model, but it doesn't affect anything for the later script. And I often prefer to separate between the topics. So in this the design definition, I'm just extracting only geometrical model from physical model. And what I use in this component is called data output. I can set the destination to stream the change in another Grasshopper definition. So that one I'm going to introduce is here. Here I'm going to use data input components to stream any change from previous script, and I only can focus on this analytical model parts. Sometimes I prefer in this way because of the size of file and also performance, and it is to maintain separate script than big chunk of script. It's already.
It's really good. It's a really good tip because you don't have to have a big just work on the one big Grasshopper file. You can just separate them into different small files, which are of course faster, and you can just open and maybe send it to different person who can work on different Grasshopper file.
Yeah, exactly. I can imagine this part of definition is architects' work who collaborate with their structural engineer. And the next script part is more scenario of structural engineer who obtain the model from the architects. And I'm just going to show you now. So if we use this data input component, and when we define the source from this example is going to be available anyway, this data output file format. If we link it, then it will stream any change. Let me go and change from here. I don't need to change actually the Grasshopper. I'll just move the one of the column as I did it before. So, but before any action, I would prefer always lock the server so we don't compute the Grasshopper definition. So we just move the Revit definition, Revit model here, and I'm going back to our architects, let's say, script. I'm going to perform that script. So you can see where is it? One of the column must be shipped, as you can see.
Can you zoom? Can you zoom a little bit better? Yeah, we can see it.
I have to focus on that, and if I enable this data output now, let me just unlock the server. I'm just moving to the scenario of structural engineer, and let's see in this case now. You will see, I'll just recompute one more time. You should be able to see. Wait a moment. Maybe because I didn't specify that it was like that. Let me change the source file, and when I come back to these components,
maybe now, maybe you can bake it, so maybe it will be easier to see.
Yeah, I'll do that. So when I now synchronize that source file, and let me bake it to Grasshopper here. Sorry, script gets heavier a bit.
Yeah, but it's really great to see that also different designers can work on the different Grasshopper files.
Yep, exactly. So we can also open RHINO viewport directly from here. And if I visualize now, you'll see this column shift to here. So that's how we can coordinate between architectural model and structural model. I'm a little bit afraid of time. Sorry, I think it's time.
No worries. We have some questions. So before that, let me see. We have from Ferenc. Stem opening can be for window and for steps. How can RHINO makes difference them when on and off? it can be important for wind pressure model.
Yeah, so I'm not structural engineer, so I cannot really answer accurately, but exactly the where, for instance, if the first facade has opening or without opening, it will impact on the loads where the surface hit from wind load, for example, or when it's flat, with opening and without opening, when we apply live load on particular use of living space, that opening would impact on the structure. So I'm here suggesting a very conceptual stage, of course, just to demonstrate these components are working. But you have in Revit, when you eventually have a analytical model, you can also go into the property and mark if opening apply or not. You can mark that yes or no parameter to close instance of openings. I wouldn't go so much deep in this details, but it's
but I think it's explained. One more question from Joel. Is this model in Revit project based in the base point? If model in Rhino 00, can you move the model in Revit base point as well? Maybe you can
so it's basically, it's a good question. So the coordination point is always based on Revit's internal origin. So Rhino will always inherit internal origin from Revit, and that's 000 in Rhino. And there, if the model doesn't matter project base point or survey point or shell point, whichever points whichever goes away from this origin point, it doesn't matter for Rhino. Rhino is only taking this point as a single point of truth.
Okay, cool. Yes, thank you for all the explanation. Let's continue to your presentation.
Yeah, so I still need about 5 more minutes, let's say. So the rest part, let's say we have geometry from Grasshopper, which slabs and wall. It's very like simplified surface and line. And this we can just simply convert using analytical boundary panel. So the surface just converted as Revit native analytical model surface. And I'm just adjusting here a little bit of parameter. For instance, the structural role we can set. If you click on the analytical surface, you see that there is a structural role. Here you can define different the role. So with the RHINO.INSIDE.REVIT, you have opportunity to get and set the parameter for Revit, and this particular components does that job. And here value is it's not string, it's just integer, because the value what Revit show is written string, but the API in this case as an input requires the integer information for structural role. So that's why I put as a number 5 to be a wall element. And you can also set the material parameter for this analytical model. For instance, each analytical model can include that structural material property, and you can also set thickness for those analytical models. And all this is possible using RHINO.INSIDE.REVIT. And also, when you look at this example, we can also convert model element as a structural element, and the component here shows like what parameters we need and what kind of what should we analyze this element as a literal or gravity, and we can define all this detail. And just for your info, for instance, analytical element structural role, when you look at again structural role, it will show simply wall. But again, this is just Revit's information panel. What we really need from as an input is structural role panel. And this, I have here a link. If you go to this page, you will see the Revit API documentation. And there
Yeah, so
you
there
can,
we can find all this information, how all the objects are named, right? All
yeah,
the
exactly.
syntax for the
So,
names.
yeah, that's what you need for the input to set the structural role. So this enumeration, you have to look up the running Revit API at the moment. And we can set boundary condition as we described. I think this example, if you follow, is very straightforward to do it. And we can also set the line load. And this component is not provided. And my colleague Ching customized with his programming skills. So I'll show you. I'll close my presentation here. You can basically extract the Revit physical model as a analytical model, and if it's necessary, you can also apply this kind of custom function using Revit and RHINO API. So if there is not more question, I would like to pass my presentation to Ching.
Yeah, we still have some 4 or 5 minutes to Ching presentation, so we can answer some question. Like Mario just wrote that he doesn't use Revit, but he can see the concept can be assigned also to Tekla instead. So good stuff, very inspiring. And yeah, this is really true that it doesn't have to be just Revit. There's some
That's the beauty about yeah, exactly. That's the beauty about Grasshopper. It's such a good bridging tool. For instance, those output from RHINO.INSIDE, this output we can also connect to sophistics Grasshopper components, and you can directly calculate the calculation model without any effort from structural engineer, which I'm saying it goes without saying that, for example, Tekla Structural Designer or Karamba 3D, all those has right link between Grasshopper and their platform. And I think SAP, the other softwares like
all the safe software, all the most. Like when I made the research and made the blog article, I think 90% of analytical structural analysis software has the live link with Grasshopper. So this is really give variety how it can be transferred. Just question about reinforcement. I know that it's always can you model reinforcement in RHINO inside Revit? To my knowledge, as today there is no native components in RHINO inside Revit. However, there are already some workarounds when you can go directly with C# or Python inside Grasshopper and use connect to Revit API to model. Do you have any experience, Junghwo?
I think this part Jing will introduce mainly from one use case today, but as long as the Revit API is available from documentation, you can actually just program it. And what is beauty? If that demand is higher, we should definitely ask RHINO inside Revit developers, and they will definitely listen to, because
there's really like RHINO developers. They are also checking what is happening on the forum. And today there were already 4 questions about reinforcement. So there will be more and more people asking about that. So they will also see that there is a need for these components. So today, in just 2 minutes, Jing will show you how we can deal without the native components. Just 2 more questions. Let me see. Do I need to complete my Revit model before exporting it to RHINO?
No, there is no export. So everything is data centric based on this streaming format. There is no import and export required anymore.
Yeah, so everything is a live link, so there is no any file. So you don't have to complete your Revit. You can just have just 50% done a Revit model and just send it to RHINO.
I think the question is more like a milestone before transfer the model to the structural engineer from architect. Of course, the design has to freeze, and you have to make sure the communication between collaborators has to be clear. But basically, when you work on the definition, there is no need for like, I mean, at this stage of model, there is no, you cannot never finish. So don't worry.
Okay, so we have some few more questions, but let's save them to later on. Ching, thank you, Junghwo. It was amazing presentation. Ching, you can share your screen, so we can go to the case when you don't have components in the RHINO inside Revit. And you can just make your own script. Maybe you can also use ChatGPT or DeepSeek or another artificial intelligence to do that. Maybe this is not the today part of our presentation, but Ching, we can see your screen. The floor is yours. So you can show us how we can actually create our own components that are not available.
Great. Then I will show this topic. Right. Then I will just use Junghwo's model to show how to add load. Use Python script, since we all talked about the missing component from the RHINO inside Revit in Grasshopper component. This adding load is missing there. If we would do it by hand, because I'm an architect, not a structural engineer. But if I would do it by the hand, I will select an analytical element and go to analyze and add the load to it, and there will be a line load, and you will see this. Then you can select this line load and go to properties. Then you can change either you can do it not uniform, or you can add different kilonewton in different directions in force or moment. Today I'm going to demonstrate how to do this part. Just grab one analytical member like this line to add this line load in this bin, and also how to unlock this parameter that you can make uniform load into it, and also you can add different force in these different directions. Just use Python, and of course this. And later on, I will show a little bit that you can also separate your Python script and put it mixed with existing Grasshopper component. So let's get into it. But firstly, I want to show a little bit structure of the this RHINO inside Revit. As we know, or maybe a little background of myself. I work a long time in architect's office. And I'm an architect turned to the software developer, especially for RHINO and also for Revit. And I did lots of plugins for Revit and using Revit API. So I'm quite familiar with Revit API. And today we're talking about RHINO inside Revit. And RHINO inside Revit is actually a external application for Revit from RHINO. So RHINO use this bridge to connect to Revit API, and also give the opportunity to use Grasshopper and its component, and also in the Grasshopper component there is a Python script component where you can also write Python script, run it into Grasshopper, and also because of this, so you can grasp directly to Revit API through this Python component, just by importing modules.
And it's much more easier. This is how I learn text-based programming inside visual programming. So it was like it's a gradual step. First, you start with the visual programming. You are getting familiar with the components or the connection, how the data works, and then you can write your text-based script inside Grasshopper.
Yeah, and also Grasshopper use the visualization to let us understand the logic of how your script is running, and that's really important. Also, how you deal with a list and an element, like in a loop, and so on and so forth. And later on, you will understand that using at the beginning with the visualized scripting, and then you can really code, because then you deal with more like a text-based coding. Yeah, and to add in a load for the component, we will, like I said, we will grasp one of the analytical model from Revit. It will be the one from the beam or related to the beam, and I will show how to create line load, like we see here above it. In Revit API, I will just go very shortly about this. You got like 3 chances to create line load in three different kind of methods. And also, we will have to set the parameter that I said. First, I want to set the parameter that load is uniform as not. So I want to set this one. And I will also show how to set parameter for the FX1, FX2, and so on and so forth, and play around in your Grasshopper script. And also, like Junghwo already showed, if you need any information from for Revit API, which you can put it into your Python script in Grasshopper, you just go to api.docs.co and search for the information you want. Like I said, I wanted to create a line load, so I would just search line load, and I will go to this page to see, oh, I have 3 different methods to create a line load. Just shortly, just for example, I need to say which document, which Revit document it is, and I have to pass also the element ID, which is the analytical member, and also to XYZ. XYZ is actually the 3D points or vector actually in Revit, and we have to pass these 2 elements, these 2 points as forces, as starting forces, and also one very important is a line load type, because each line load it has also a type like every other element in Revit. So
API docs is like a recipe. Every time, and if you would like to find something, you are opening this book and just go through all the steps that you need into as an input and what you get as output.
Like a recipe library, a huge library. But this website, it's very useful because you can just search for it. Because it's a lot of stuff you can control, not only the element, you can also control UIs and also add different kind of stuff. You can I don't know, add walls, add the rooms and everything. Not everything. I think I have like 8-9 years experience with RHINO API, Revit API. Sorry, I think there are maybe 95% I can get everything what I can do by hand to make it as a plugin. 95, maybe 97.
It's a good result.
It's really enough for your daily work, and that's also what I'm good about, to create a specialized workflow for your daily job, just by adding different plugins. All right, so we should get into script. So if I can find my, all right, where's my, sorry. Yeah, here. All right. Let me just open my Grasshopper environment. So let's jump into the code.
Yeah, so this is a Python 3, I suppose, that is available in RHINO 8.
Yeah. Oh, sorry. Now maybe you can also search for this component, just type Python, and you will find this component as Python 3 script. And then if you can create one and you double click it, you get into the script. Everything you write inside this, it will be run also in the background as a part of this external application. I mean the RHINO.INSIDE.REVIT, and as a part of the command. And I will just go very quickly through it. Like I said, and I also really like to get into the main point of what I'm doing. So I will grab some elements like this line load into my script. It would just be this input of E, and I would just.
Can you just please make it bigger so we can just fill it in the full screen? So like, if you can just also make a font with I think with the control and the scroll, the different way. And if you make it wider, so we can see more better.
About this.
It's much it's much better.
Okay.
For those who are watching on YouTube, you can also zoom a little bit to it.
All right. For creating Python scripts, usually you have to import the modules, the tools that you want to use, like the libraries. And sorry, the first two lines is that you're telling your Grasshopper, hey, please import Revit database namespace, which is also a name of like a module that you can query what you want and to modify it, what you want to do in a database. And also the UI is a library that you can manipulate the Revit UI. And this is also an important like library. It's a RHINO.INSIDE.REVIT. This is where it's a sort of the library that you can get like which document of the Revit that I'm query at, and you need to go through this point. So let me go to this line load create. Like I said, I like to get into the main point. If I want to create a line load, what I need to call the line load and .create, like we said, we see it in the API docs, and give it all these elements that it needs, like the document, which Revit document it is, and which element we are talking about, which is this analytical member, and also these two forces, and the one moment, and also this type line load. So the question is now, okay, the document, we can get it from this library, like we said, okay, the UI document means a document for the whole buttons and the buttons and all what you see here, and all what you see the viewer, then and the toolbars and so on and so forth. And from this UI document, which is the active document, is what you're opening now. Under this, you can get the Revit document, which is using UI document. So this is the Revit document, the file that you're dealing with. So you
don't have to install anything. It's just enough, just writing import, and it's just enough, and it's connecting to Revit automatically.
Yes, exactly. Yeah, and then the second thing that you need is the element. Oh, sorry. This element is what we passed through the input. This E. This E is like this element that I selected by right click on it and set one graphical element. Then you choose this, and then you choose this this analytical member. I will just do it now. You can see. So you have to choose this one. Oh, there's some error.
Oh, we don't like bugs. Maybe you haven't clicked the right element.
maybe. Let me see. Oh, this is some error that usually sometimes you will meet because of the transaction part. This is also error for learning because of Revit. Revit, if you want to change anything in your RHINO document, then you have to open a transaction to start a transaction and make your change, and then committed it, and then the change, if there's no error into it, then the change will be made. However, this is because of this Python script is inside a Grasshopper, and Grasshopper itself already opened a transaction. And but if you want to create or change anything, you need to open another transaction. And this is some problem that Grasshopper get some kind of or Revit get some sometimes confused that which transaction is now open. So it's saying starting a new transaction is not permitted, which means there is the Grasshopper is open. Usually it worked, but if I just because I load this command, this script already, and then I change a little bit the element, and it got a little bit confused for this another transaction. However, you just closed it, and if for
that's old trick that works, that if you open and start again, it works.
Yes, it works. But I have prepared also another one, so we don't need to in case. Yeah. Oh, yeah. And this is the same. Let me see if it works. Oh yeah, it works. Oh, thank God. Okay, I can still open this one. I prepared this another one because I want to see the mixture of a Python script and Grasshopper component. Anyway, I will go make it a little bigger again. I would
even bigger. If you can just make even bigger. Yeah.
Okay. All right. How about this?
Yeah.
It's okay. All right. Okay. We said we want to create a line load, so we have document and element ID to get into it, and the force and the moment and the type line load. This is the part that I want to talk about, because you have to give a type. If I select this one, it's what's already created, and I go to wait.
I think you have this Python script was disabled.
Oh, no. I have another one there. Sorry, I just want to show this. I select now the line load, and you will see there the line load also has a type, so you have to pass the type to it. And how do I get this type? We can just go through to grab a default element type ID. This is these two lines about. I have a variable which is called type line load, and I go into the document, get element, and which kind of element is I want to have the default element type ID, query it from the document, and pass through which kind of element type group is a line load type to it. So I will have this type line load, which is showing here, the line load 1, and I just have to pass this to this method, and it will create this line load. Okay, this is the first thing. And the second thing is I want to change the parameter. First is this uniform load. I wanted to make it ununiformed. Basically, if you just create a line load by hand, it will be uniformed. So you have to get the parameter, and in this case, if you can see it here from the properties, and this is normally a built-in parameter. So you have to go through the building parameter. It's called struct, and you can go through all this a whole list of the building parameter, and you'll find a load is uniform, and pass this building parameter to get parameter method, and then you will get the parameter uniform, and then you can set it as 0. So 0, 1, which means it's a true or false, and you pass this 0, then the uniform load will be unchecked.
For sure, it's not that not that easy to grasp if someone is just starting with programming and so on. But the idea here was to show you that it's possible to create components that are not possible. So here, so this script you are going to share, right, for people who registered for. So everyone who registered for this workshop, so you will get it. So on your free time, so you can just through step by step and see how it's working, and also create your own live load. Okay, time is running. We have some question. Would you like to add something more to round up your presentation?
Yeah. The final step is what is only set up the other parameters, which is use the same thing, like use for this uniform part, and you pass through this the value to it, and then you can play it around like this. Let me just do it a little bit, and you will see in the screen that the load is changing. It's parameter. And the final part is I can just split this script, and I just put it into only one. It's very short. It's only create line load, and the other things like grasp the parameter and give it a value. It's already existing in the default component. So you can also do this way, and this way you can do it like visually, and it makes your script also more clear and more manipulatable. And that's it.
And this is just on the line load, but you can create the same with the point loads, with the area loads, and so on.
Yes, exactly. What you can get from the API docs. You can go through that. If it's not in Grasshopper component originally, you can go through from the Python script.
Perfect. Okay, let's go to. Thank you for this presentation. I think like all the audience get the idea for how it's possible to create it. It's much more complicated than just starting with the RHINO.INSIDE.REVIT, but this is how it's done. So we start first with visual programming, then you go to text-based programming, and you create on components. So the main idea was to show you that you don't have to give up if you don't see components that you need. You can use Python to create it. Have you tested, Ching, with some of the ChatGPT to create some Python script? Have you tested to use AI to create Python scripts?
Yes, but not for a Grasshopper, but for the other stuff like.
And what is your experience? What is your experience?
But basically, I would recommend anyway. You need a little bit programming knowledges, because they GPTs will also make errors, and you have to try it. And if there is any error feedback, you can pass this feedback to the ChatGPT, and it will improve itself. And but you still need a little bit let's say independence for that, because
and understanding.
Yeah, and also sometimes it gets a little bit confused, and the code that it suggests will be even more complex. But you have to, know a little bit to tell him, no, this is too much, and to come back a little bit what you really want. So that's a good input actually to try it around. Yeah.
But for those, we recommend to first start with Grasshopper because it's the best way to start with the visual programming. And for everyone who is interested in starting how to use Grasshopper inside Revit, together with Junghwo, we have prepared a guide with all the steps, where you can install all the software, how you can connect RHINO, Revit, and Grasshopper together, and how you can make a simple step. So if you find Dynamo slow and limiting, so Grasshopper can be really powerful alternative. So I sent the link, so grasshopperinrevit.com, so you can get a guide. Okay, let's go to some questions. So we have here. So maybe we can start from Gerald. Are these workflows that you guys today presented are possible in all Revit versions? I assume that Revit 2025 it's possible. What about different all the others Revit versions?
After 23, this analytical model API was introduced to generate, which detached from Revit physical model. So what we show today is available if you use after Revit 2023.
Mm-hmm. Perfect. From Christoph, I don't fully get how to approximate slab heights from the video. The architectural model differs from the structural one, and I find it hard to reverse the process due to some simplification. Junghwo, maybe we can just say what is your experience on this all simplification for slabs?
Yeah, so in this case, I think assuming that it's compound slabs, including the core structure. What I mean approximate is we only take into account of structural slab, not the architectural slab. So from the structural slab, the whole thickness, if it's 100, you can not approximate, but you can make analytical surface in the center or top or bottom of surface to get the. And if the slab profile is a bit complicated, with many slab edges, then usually structural engineer will determine how to simplify. And for me as an architect, when that feedback comes, I'm just reflecting on that simplification from structural engineers, what they need.
Yeah, and you can make this all simplification in RHINO and Grasshopper with all native components, and you can simplify it as you would with a bounding box, or maybe you can just delete some edges, or maybe combine them into one. Let's stay with this similar topic from Joel. Is it easy to transfer the number of story changes, like from 4 to 5 levels, or vice versa? Will take a while update the model. What is your experience? Have you created for like just changing the number of slabs?
I tried with really large project which is over 2.5 kilometers length and 800 meters height for one building. It crashed. So when it changed, level changed. So this depends a lot on the complexity or size of project. But generally speaking, for that kind of size of project, need some more beam strategy to split the model. But if I say just general size, high rise up to 40 story, I didn't have any issue to adopt the instance changes.
And it was also a great tip that you show also how to divide the script, a Grasshopper script, as a one part for columns and slabs, second one for creating analytical model, not just do it everything at the one. What was question if the recording will be available and where? So recordings will be available for registration. So maybe I can just put it on the script. So we are going to send tomorrow morning all the Revit file and Grasshopper and Python file for everyone who register for learngrasshopper.com/Revit structure. So you can get the recording and all the materials. Okay, there's more questions. So let's go. How do you deal with modeling element joint intersection like beam to column and slab?
Yeah, My method, if you look at the definition clause, I just elongate the start and end point of column and beams to intersect with the slab surface. And from there, I shatter the line based on the closest point of meeting points between slab and line. And that shattered middle line is going to be the final analytical line for beam. And I mean, there are, I imagine there are many methods, but that's what I use for this definition.
Mm-hmm. We really need Grasshopper to handle steel joint part elements like steel plates, bolts, etc. in Revit. At least Grasshopper can import native steel plates elements into BREP elements. Do you have any experience with the steel plates in Revit?
Basically, RHINO.INSIDE.REVIT doesn't provide any native components for steel connections, but what would be interesting is that you can, as Sandra mentioned, you can get the geometrical representation of those connections in Grasshopper, and this Grasshopper data you can stream to advanced steel or Tekra structure with their own connector. So at this point, I have to agree the steel plate and steel connections and etc. in Revit is not as intuitive as Tekra or advanced steel. But as I said, when API is available, the developer from your organization could program that part if it's not if that is really need, we should push in community, because what I like about Grasshopper is community driven, pretty much open source. So we could address these features to RHINO.INSIDE.REVIT forum, and if there's strong demands, I'm sure they will develop. But
after today's workshop, I'm pretty sure that we should more push for reinforcement and steel plates and steel elements. Okay, thank you for that answer. Christoph is going further with this slab simplification. For example, the slab is a different height level or thickness. When you approximate it, there will no longer intersect with the base level. This is true, but actually we can also change the column's height, right? In this case, if there's...
Exactly. So what we do is following the sketch I did. Basically, if depends on, like, let's say there are jumping slab and we align to same level because it's not much deviation. And because of this slab goes up, there will be another gap between column to the slab analytical part. Then, of course, that column has to be elongated to meet that jumping slab moved. This is all has to follow these rules, what calculation software needs.
Yeah. So remember, not just only slab, but we also going to make simplification of the columns or beams, because if we are going to simplify the slab, so we have to also make simplification to other elements and maybe make it wider or some of them thicker.
And there are something I didn't introduce in the concept. There is a link, listed link you can set, even though there's gap between, let's say, slab surface and column. If you are sure about this connection, you can set the link. The link you can determine a different fixed condition, and that it basically, if you just need to calculate, it will calculate what they need. And also in Revit, what Dynamo good, they prepare this automation. If there's just some tolerance which the model doesn't meet, you can just use that Dynamo script that will kind of connect all the missing parts. But I mean, there are so many opportunity and chance you can improve different solutions. But basically, it must follow the rule that what structural calculations often is.
Ching, question to you. Is there any difference in the accessing Revit API between C#, Python, or other different languages? What is your experience and put on that? Is Python enough, learning Python for accessing Revit API?
It depends. If you want to use, there are some intermediate tools, let's say, like use Grasshopper running inside Revit. Then you can communicate with Revit API through the component, Python component that we see today. I saw today with Python. If you wanted to really create a plugin or create even an application for that, you probably need to learn C# or F# to create a dynamic linked library, which is the famous DLL file. And then you can use it as add-in, put it into Revit. Yes, like if you learn C# or F#, you can also create a Grasshopper component, which is you can also create your own component in that and create also this line load component in Grasshopper for your own usage.
But Python is easier to start with, right?
I started with Python. Yeah, and if you really get into the programming, you learn from one and you understand what's the logic, and you will go to another. Because once you have this logic in your head, then it's only the matter how the form in the language is. And you just have to learn how the syntax is. It's like learning language, English or German or Chinese.
Yeah, thank you for that answer. And I would like to invite all of you for the next workshop about RHINO inside Revit. And this time Ismail Sans will be my guest, and we are going to talk more in depth that Junghwo just showed us today. What are the best practices for geometry and data flow from Revit to RHINO? So Junghwo today show how to export from Revit inside RHINO walls with the windows and doors and columns. So we are going to go more on depth. We have Ismail who's going to share his experience of that. I will also put a link, so if you are going to register, so you will get all the reminders for the next workshop on the 19th of February. So it will be at 2 p.m. Central European time. That's all for today. I do not see more questions. Thank you. It was an amazing session. Thank you for that you're sharing. Please continue making your YouTube channel. I will also put the link for your YouTube channel. Maybe you can just say a few words, Ching. What are you mostly doing on the Spot channel? What kind of workflows are you showing?
I'm showing like RHINO inside Revit with Python is one, and also I will show F# plugins, how to create it. And also, I'm also looking to the IFC Open Viewer for the Net Open company, which is based in JavaScript, TypeScript, like web app, this kind of things. That's all I'm, playing around.
And you, Junghwo, what are you mostly playing around there?
I'm going to continue with Ching regarding RHINO or Grasshopper workflow, as well as I'm interested in metaverse. I titled myself as a metaverse architect. You see my building behind. More interactive visualization using different technique. Also reality capturing, like, I don't know, Gaussian plattings and photogrammetry and all this technique we can use it for building technology. I'll try to encourage this direction further.
Perfect. You got lots of good comments. from Dragan, from Christoph. Okay, thank you. A really good context, lots of good comments. You made really great work with this presentation. So thank you again. I hope you are going to be my guests for the next workshop about this topic. Maybe with you, Ching, we are going into depth and start from the scratch how we can write new components in Python. So maybe in the more, just also write in comments if you are interested in that in Junghwo. Maybe we can also make it in depth and going maybe into Sophistic, maybe to Karamba, to more analytical software. What do you think, guys, about that?
That's cool.
Why not? It's cool.
That's great. Yeah.
Let's do it. Thank you. Thank you for that one, and yeah, hope you to see in the next one. Bye.